Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here, and in this video we're going to be looking at sets and Venn diagrams. So by the end of this lesson you'll be able to do these two things: use Venn diagrams, set language and notation for events, and use the rules. The probability of not A is equal to 1 minus the probability of A, and the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So let's have a look at part 1, Venn diagrams, set language and notation for events. A union B means A union B, and is a set of all elements in set A or B. Okay, it's a set of all elements in set A or B. So that means this union symbol means OR. And when we're talking about that in terms of Venn diagrams, it means everything inside the circles. A intersection B is the set of all elements that are in both sets A and B. So here, when we see that symbol, it looks like the letter N from the word AND. So that means A intersection B, where they cross over. So here I've got the two Venn diagrams. A union B, A or B, means everything inside the circles. That's why everything inside the circles is colored blue. And A intersection B, or A and B, represents the part where they both overlap. Okay, that's why only that section is colored blue. The complement of an event is everything other than that event. For example, the complement of owning a red car is not owning a red car. Okay, you can't say the complement of owning a red car is owning a black car, because you could own a blue car, or silver one, or a grey one. Okay, so the complement of owning a red car is not owning a red car. It could include not even owning a car at all. Okay, or the complement of enjoying action movies is not enjoying action movies. So I always like to use the word not in front of it, in front of event for the complement. I think that just makes it nice and easy. Now we use this notation. We've got A bar, or A dash, or AC for the complement of event A. So there's 3 different ways of writing these, the notation for complements, but I like to just stick with this A bar. So let's have a look at some examples. Here we've got people were surveyed about which flavor of ice cream they prefer, vanilla and chocolate, if they like both. These people like both. These people like vanilla only. These people like chocolate only. And these 4 people don't like vanilla or chocolate. So we can see. Let's have a look at question A. How many like vanilla? All of these people like vanilla. That's 35 plus 21, which is equal to 56. How many people like chocolate? Well, all of these people like chocolate. 21 plus 40, that's 61. How many people like vanilla and chocolate? These people like vanilla and chocolate, that's 21. And how many like vanilla or chocolate? Remember, in probability, the word or actually means and slash or. Okay, so it's actually everything inside the brackets. So all of this, that's how many people like vanilla or chocolate. So if we were to add them all together, we get 56 plus 40 is 96. 96 people like vanilla or chocolate. Okay, let's have a look at part B. Type of book. This time we're not just working out the number of elements in each set. We're talking about probability. Find the probability. So let's just assume that people were asked, a group of people were asked whether they like fiction or non-fiction, or both, or neither. So we're finding the probability that if a person was selected at random, that they would like fiction only. Well, these people here like fiction, But these ones like non-fiction as well, so we don't include them. We only want this 12. So the probability that someone was selected at random, like fiction only, is 12 out of the number of people that were surveyed. Well, that's 15 plus 15, that's 30. So 12 out of 30 people were surveyed, like fiction only. Now we can always simplify that. Let's divide that by 6, that's 2 over 5. Alright, the probability that they like non-fiction. All of these people like non-fiction. So that's 15 people out of 30 that were surveyed. That's half. Okay, I'll do one more with you, and then I'll do 2 more with you, and then maybe you can have a go with E and F. So this question here says, if someone was selected at random, find the probability that they don't like fiction. Well, these people don't like fiction. Same with this. There's 12 people who don't like fiction. 12 out of the 30, which we know is 2 out of 5. Okay, another way of thinking about this is that the probability that they don't like fiction is 1 minus the probability that they do. So if we write that out here, probability that they don't like fiction is 1 minus the probability that they do like fiction. Well, how many like fiction? 18 of them do. Okay, 18 of them out of the 30. So that just gives us 12 out of 30, which is 2/5. We'll get the same answer either way. Alright, let me have a go with question D with you, and then you can pause the video and have a go with E and F. Find the probability that someone selected at random likes both fiction and non-fiction. Okay, it's always important for you to remember what that symbol means. That means and. And because that's and, we're talking about the intersection where they overlap. 6 people. Only 6 people out of the 30 like both fiction and non-fiction. So that's 1 out of 5. Okay, pause the video, have a go with question E and F. Okay, let's have a look at your answers. So for question E, we've got the probability that someone selected at random likes fiction or non-fiction. Okay, so remember that union means or, which is everything inside the circles. So we add these 3 numbers together. We've got 15 plus 12, which is 27. So that's 27 out of 30 like fiction or non-fiction. We can divide that by 3, so that's 9 over 10. Find the probability that they don't like, because of this bar, they don't like fiction and non-fiction. Okay, just and. Well, these 6 people like fiction and non-fiction. Therefore, the rest of them don't like both fiction and non-fiction. So if we were to add those numbers together, we get 12 plus 12, that's 24 out of 30. Okay, divide that by 6, that's 4 out of 5. Okay, so just remember, whenever we're talking about finding the probability, it's always going to be a fraction, or percentage, or decimal, but fraction's the easiest. Here, we're just asking for a number. Question C. Draw a Venn diagram for the integers from 1 to 10, given that A is equal to 1, 3, 4, 5, and 8, and B is equal to 3, 6, 8, 9, and 10. So what this means is that in this event, or in this set, belong these numbers, and in set B belongs these numbers. So I'm going to draw my Venn diagram. Remember, you must have that rectangle on the outside. Don't just draw the circles in the middle and that's it. Okay, and make sure you label your sets as well. So I'm going to label this set A and set B. Okay, otherwise the examiner won't know which set you're talking about or you're referring to. So make sure you always label it and have that rectangle on the outside. Often students forget to draw that rectangle, but there's always numbers that, or there might be numbers that don't belong to either set. So what we're going to do is we're going to look for how many numbers they have in common. So they both have a 3. They both have an 8. So that they have 2 numbers in common. That means A has 3 other numbers. B has 3 other numbers because they've got 3 and 8 in common. So these are the 3 other numbers. So if we add these 3 numbers here, 3 plus 2 plus 3, that's 8 numbers accounted from 1 to 10, which means there are 2 numbers that we didn't include. So we need to put that 2 on the outside. Okay. Question D. How would you describe the shaded regions in set notation for each of the examples below? Well, we can see here that the shaded area is where A and B overlap, where they intersect. So this has to be A intersection B, A and B. Here the shaded area is everything except A. So that means it must be not A. Why don't you pause the video and have a go with the last 2 yourselves? Okay, so let's have a look at this. So in the third one, it looks like what's shaded is only B. Okay, because it's not just B, because B includes this bit, but that bit also includes A. So it looks like it's B and not A. Or if you want to write it the other way around, not A and B. For the last one, we can see that what's shaded is everything except the intersection between A and B. So I might write the intersection of A and B, but it's not that at all. Okay, let's have a look at part 2 of this lesson. Using the rules, the probability of not A is equal to 1 minus the probability of A. I've sort of referred to this previously. And the probability that A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now it's important for you to remember that this second rule here, this is given to you in your formula sheet. So that's given in reference sheet. But this one isn't. You'll need to memorize this. But that formula there for the complement of an event should be pretty self-explanatory. Okay, let's have a look at some examples. 200 Sydneysiders were surveyed to find out how many of them visited the cities of Melbourne and Brisbane. The survey showed that 63 people had visited Melbourne, 51 had visited Brisbane, and 24 had visited both. If a person is chosen at random, find the probability that they visited Melbourne or Brisbane. Now, what we could do here is we could draw a Venn diagram, or maybe we could use this formula up here. So according to this formula up here, the one in yellow, we can see that the probability that they visited Melbourne or Brisbane is equal to the probability that they visited Melbourne plus the probability that they visited Brisbane minus the probability that they visited both Melbourne and Brisbane. So how many people visited Melbourne? We can see that 63 out of 200. because there were 200 that were surveyed. Who visited Melbourne? How many visited Brisbane? 51. So the probability is 51 out of 200. And how many visited both? 24 out of 200. So if I were to put this in my calculator, 63 plus 51 minus 24, that's 90 out of 200. Okay, I could just do that because my denominators are all the same. So I know my denominator is going to be 200. And that would just simplify to 9 out of 20. Now, if you wanted to use a Venn diagram, you could. Okay, so let me just get my Venn diagram. I'm just going to draw my two circles. We've got Melbourne and Brisbane. We know 24 have visited both. Because 63 people have visited Melbourne, the number that I need to write here is 63 minus the 24. That's 39. Because 51 people have visited Brisbane, 51 minus 24 is equal to 27, and that's what number I'm going to write there. And so if we were to add those three numbers together, 39 plus 24 plus 27, we'll get 90 out of the 200. Let me just complete this Venn diagram because there is a number missing, and that's 200 minus 90, which is 110. Did not visit either Melbourne or Brisbane. Alright, so how many find the probability that they visit neither city? Well, that's just 110. Probability that they visit neither city is just 110 out of the 200, or 11 out of 20. Now that's one way of doing it. Okay, the other way is to use the complement rule, that the probability that they visited neither city is equal to 1 minus the probability that they visited either one of them, Melbourne or Brisbane. So that's 1 minus, well, we've already worked out Melbourne or Brisbane, which is 9 out of 20. And that's how we get 11 out of 20. Okay, so this is an alternate way of working it out. Alright, last question. How about I get you to pause the video and have a go with this one yourselves? Okay, in a class of 27 students, 18 play basketball, 14 play cricket, and 7 play both. What's the probability that a student chosen at random plays neither basketball nor cricket? So I'm going to use a Venn diagram. We've got basketball and cricket. I always like to start with the both. 7 play both, so put that in the middle first. Because 18 people, or 18 students play basketball, we've already accounted for 7 of them, so 11 must play basketball only. Okay, 11 plus 7 is 18, so 18 people play basketball. What number do I need to write in here? Well, 14 people play cricket. I already have 7 of them, so I need to write another 7. That means if I were to add these numbers together, 11 plus 14 is 25. That means 2 people, because there are 27 students, 2 students have not been accounted for, and they don't play either basketball or cricket. So that means the probability that a student that's selected at random does not play basketball or cricket has to be 2 out of 27. Okay, and that's it for this video. Thanks.